Okay, so we're going to take a look at some core concepts. And we're going to look at these functions. So the first thing to understand is that the robot is this thing called a state machine. And a state machine is just going to describe how something behaves. Don't worry too much about that. Just know that if you're in a state machine, you're going to act a certain way until something happens, and you're going to change your behavior. That's the idea here. And so that thing that happens is a trigger, and moving from one state to another is a transition. And a state, again, is just how you're acting. So we said the robot is a state machine. And so here's kind of what you can, like if you visualize a state machine, what to look at. You start here, and then you go to state A. If condition 1 happens, something happens, now you're in state B. And then you stay in state B until either condition 2 or condition 3 happens. If condition 2 happens, you go to state C. In state C, if condition 5 happens, you go back to state B. All it's saying is that things happen and you need to be able to change your behavior, right? You're kind of a state machine, right? You're all good, you're chilling, you're having a good time, and then you're hungry. All of a sudden, you're mad, you gotta go get food now, right? You're gonna act differently. That's what this is saying, is that you behave differently depending on the conditions. Right? So the robot actually has 3 different states it can be in. The disabled state, the teleoperated state, and the autonomous state. Anybody want to take a stab at what any of those states means? Go ahead.
Autonomous is like acting on its own.
Autonomous is acting on its own. Okay? What do you got?
Teleoperated, I would assume, is someone operating it from the outside.
Yep. So you've got an operator involved here. Okay?
Disable means that no code's running, it's just off.
Close. Very, very close. I'm just going to say nothing for now. So those are the states, right? And so they're not describing exactly what the robot's doing, but it is describing kind of when you're in that state. Now there is a 4th possible state called test. Test is a special state where you're just testing code, and we'll talk about that. It is not happening during a match. So let's talk about the disabled state. The disabled state is when the robot is not enabled. So the code is actually running, but the robot's not doing anything. If you're looking at the robot, how many of you seen an FRC robot like on and moving, right? If you've ever seen on, there's a blinking orange light. That's called the robot signal light. If that light is blinking, the robot's enabled. If that robot is solid, the robot is disabled. And all it means is the actuators will not respond. Motors won't turn, pneumatic cylinders won't fire unless they lose air, right? But things like sensors still work. So if you've got code saying, hey, tell me what this sensor's doing right now, that code will still run even in the disabled state. So it's not so much that the code's not running, it's just that the robot can't do anything. There's a few different ways the robot can become disabled, but we'll look at that for a later time. All right, so we'll look at autonomous next. Autonomous is an enabled state, which means the motors will turn, the cylinders will fire, but the sensors will function. But there is one key thing here. So even though the motors will turn, it ignores driver inputs. So even if you're moving the joysticks, the robot will not respond. It ignores that altogether, as long as it is in the autonomous state. And we'll talk about the conditions later. And the last big state is the teleoperated state. Again, it's enabled. You can still have motors, so motors turn, pistons fire, but driver inputs are now processed. So whereas before in autonomous, you wiggle the joysticks, nothing's happening, now something will happen because the robot responds in the teleoperated state. So here's the state machine for a robot. So the robot is on the field, we're getting ready. The robot is disabled. As soon as the match starts, you transition into the autonomous state. As soon as autonomous finishes, you'll go back to the disabled state. But you're only there for like a very, very short amount of time, because as soon as auto is over, you switch over to teleop, and then you're in teleop state. And then when the match ends, you go back to the disabled state. So it's a pretty simple progression. So how long is an FRC match?
Never been to one. Don't know exactly.
Merrick?
Yeah, I just don't.
Merrick, how long is an FRC match? It's a little bit more than 2 minutes. It is. It is 2 minutes and 30 seconds. And the first 15 seconds of that are auto. And then the remaining 2 minutes and 15 seconds are teleop. So the match starts. Robot's very briefly disabled, and before the match it's disabled. Match starts, boom, go to autonomous. Do that for 15 seconds. Boom, back to disabled for a split second. Boom, teleop. Match is over, disabled again. You can't control that. You have no control over that. But what you do have control over is what the robot does when it's in those states. For those 15 seconds, you define what happens in autonomous. For those 2 minutes and 15 seconds, you define what happens in teleop. Again, you can't control the changes. You have no control over the transitions, but you do have control over the states.
What if we just make a robot so fast that it slows time down?
That would be impressive.
If you could break the speed of light.
Yeah.
You could break the speed of light.
Big note here though. Robot will only be in one of those states. You can't be in auto and teleop. You can't be in auto and disabled. One at a time. So you will never be in more than one state. So that's why your code won't conflict if you do one thing in auto and one thing in teleop. Again, the program automatically changes for you. Now we have these other things called pseudo states. I'm going to talk about them. Don't worry a whole lot about them. But they're kind of like states in that they define what the robot does. But unlike the states, you don't transition between them. You're just either always in them or always not in them. And there's two of them. One is called the robot, right? The robot is always a robot. Does that make sense? So it is always in the robot pseudo state. Whether it's a real robot or a simulated robot, it's still a robot. But there's also the simulation pseudo state. Is a real robot simulated? No. But a simulated robot is simulated. And these are just helpers for you to define extra behavior. Maybe there's a thing you want the robot to always do, whether it's disabled or autonomous or teleop. You don't care which one it is. You want it to always do that thing. Put it in the robot. Maybe there's this thing you want the robot to always do, but only when it's in simulation. Put it in the simulation. Anything that's like super mission critical probably needs to go in one of the states. I've got some charts here. I don't worry about that. Okay. Before we get to the next piece, are there any questions on those idea of states? You've got teleop, auto, disabled. Those are the ones you'll see in a match. And then test, which is a separate special state you can use outside of a match. Okay. So let's look back at the code. And we'll see some of this, right? Line 27, autonomous. Line 30, autonomous. Teleop, teleop. Disabled, disabled. Those are your three key states, right? Test, test. There's your fourth state. Simulation, simulation. That's your pseudo state for when the robot's in simulation. Robot, robot. That's your pseudo state for when the robot's a robot. But is there anything you noticed just then when I went through all five of those? And by all five, I think I mean all six. Yep.
All of them have an init and then a periodic.
Yeah, there's always two. There's always an init. There's always a periodic. Raise your hand if you've ever played with an Arduino.
No, what?
An Arduino. It's an Arduino. It's just a little. It's basically a microprocessor. It's a way to prototype and do some projects. Merrick, have you written code for your Arduino? How many functions are there when you write code for your Arduino? So if you've written code for an Arduino, this is going to look somewhat similar, because Arduinos also have this concept of initialize and loop. And that's what all these are. Every single state and pseudostate has two parts to it. There's the init and the periodic. The init, let's see if I want to talk about the app. So the init is an initialization. It is a way to get set up. It is only going to run one time. And I say that, it's a little misleading. It's going to run one time every time that thing starts. So looking at teleop-init. When do you think teleop-init is going to run? When you switch to teleop. Which time you switch to teleop, it's every time. So the first time as soon as teleop starts, you're going to initialize it. Every time. A good example is going to be looking back at this chart. So if I were to look at these guys, how many times do I enter the disabled state? From start, there's 1. From auto, there's 2. And from teleop, there's 3, right? So I enter the disabled state 3 times. That means disabled init is going to run 3 times, because it's not just the first time you enter the state, it's every time you enter the state. And this is actually a simplified chart too. If the robot loses connection and then comes back, it has to go back to the disabled state. So every time you enter the disabled state, it's going to run. And the point of that is to get it ready, right? Maybe you don't know what condition the robot was in at the end of the last state, so you need to get it ready for the new one. That's the point of these inits, is to get the robot ready for the new state. So autonomous init runs at the start of autonomous every time you start going into autonomous. So if you're in the middle of autonomous, robot disconnects, and you come back, you went into autonomous 2 times. So you initialize 2 times. Teleop init, same deal. You go into the robot disconnects 5 times. You go into teleop 5 times. You initialize 5 times. Disabled, same idea. Test, simulation. So any code you need to run 1 time at the start of something are going to go in the inits. What's an example of code that's not going to run just 1 time? Periodic is where you would put that, but what's something the robot can do that you wouldn't want to do just 1 time? Check a sensor. I want to constantly be checking a sensor. What's another thing? Say it again. If you had a system, an alignment, you want to constantly be aligning, just moving, right? The robot should constantly be moving, but you have to change every time. If you just say, hey, run in the initialization, it's going to run, and then that's it. That's all you get. You're actually going to put very little functional code in those initializes, right? It's just to say, hey, reset this counter, or restart the timer, or go to 0 speed for getting set up. It's these periodics where important stuff happens. Let's see if I've got anything to talk about there. Did that. Yeah. So the periodics, it's code that's run pretty continuously. Now, one of the things you will see in FRC code, and I'm gonna go to the iPad of this because I want to draw this and make sure we have it. How many of you have seen something like this before? This is called a loop. In programming, you will write loops sometimes. In FRC programming, You will almost never be writing loops. I'm not going to say never, but almost never. In general, you will not be writing loops in FRC.
Would you write loops for the testing? Like when you're testing, could you write loops?
You still wouldn't do it there probably.
The loop will infinitely do it
Why?
because it's going back.
Because
It would say why.
what is that word? Periodic. The periodic function is a loop. So if you write a loop, you're putting a loop in a loop. That's the issue. Now, how fast does this code run? This periodic function is going to run about every 20 milliseconds. So what is that, like 50 times a second? Which means if you put something in the periodic function that is also a loop and takes a long time to run, by the time it finishes running, the robot could already be on to the next call of the periodic function. So it's saying, hey, step 1, run the function. I'm still going, but step 2 is already up here, so I got to start step 2. And so now I'm trying to run step 1 and step 2 at the same time. So again, there are times and there are places to write loops, especially in regular programming and to some extent in FRC programming. But especially early on, you should not be writing loops. If you find yourself writing a loop, you are probably not doing something you're supposed to be doing, just in general.
Unless you want to sabotage the team.
Yeah, right?
Don't break the robot.
Okay, are there any questions about that concept of init and periodic? So yeah, you've got, for autonomous, you've got an init and a periodic, and then you've got these. So, for example, match just started, it's time to go, auto starts. I run autonomous init, and then every 20 milliseconds, give or take, don't expect that to be constant, I run autonomous periodic. Run it again, run it again, run it again, until autonomous is over, and then what happens?
You go to autonomous init.
You got the
Or
disabled.
I go to disabled
init.
init,
And then you run.
and then I
Run
I go to disabled periodic until,
It takes you to teleop.
and teleop starts, what do I do?
Teleop.
Teleop init, and then
Yeah, periodic.
teleop periodic until,
Until we go back to disabled.
which happens when?
The round is up.
When the match is over, I go to teleop, I'm over, so I go to disabled, how do I go to disabled? I go to disabled
Init.
init, and then
Disabled period.
disabled periodic. Just looping, 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 looping.